Today we are going to cover the topic of the class organization, in which we will talk about how do we design a class properly and how can we make it neat and clean. So basically the way we can organize it and the way we can save our memory as well. Hello everyone, this is Meedhansh and welcome back to the Java series. So without any further ado, let's get straight to our screen. So let us start with the class organization and we will take the example of the class circle. So basically we are going to create a class which is named circle, and we will basically have all the parameters which are required for the circle. We will set them and we will see all the different types. So basically we are going to implement many things which we have learned previously, many keywords as well. So let us start by designing it. So inside the class circle, now what are the attributes which are possible for a circle? We have the radius, diameter, area, circumference, then we have the pi. And let us save it. We will name it as circle.java. Simple. So we have the class circle, we have a total of 5 attributes: radius, diameter, area, circumference, and the pi. Now let us create a constructor. So what we are going to do is that we will get the values via the moment the object is being created, and we will take a parameterized constructor. So the value which will pass is the radius. So we will take double, let's say r, and below inside the constructor we will simply give the value radius is equal to r. Simple. And we will save it. So then we will create let's say another method which will be public void, let's say show result. So result in the sense that we are going to calculate everything and thus we will show the result. So first off we will check that if it is working or not, like are we getting the value for radius or not. So okay, so we have the system dot out dot println, let's say radius colon plus radius. So this is the way we concatenate the strings. So first I had a string which is the double quotes, then I added the concatenation symbol which is the plus sign, and then I put the variable. Same thing for the others. So we have in total 4 things. The 5th one is pi, but we do not necessarily need to show the pi. Diameter, we have the diameter, then the area, we'll keep it small, and then the circumference or perimeter, anything. So circumference is more appropriate for the circles, otherwise we use the perimeter. Let us save it, and now we will open our file which is the demonstrate file. So let's open it, open and demonstrate. So inside the demonstrate, now we are going to create the object. Circle, let's say C1 is equal to new circle, and inside this we are going to pass some value. Let's say if I pass let's say 5.3, since we are using the double, and by default Java uses double, like in the integer category it's the int as the default, in the float category double is the default value in which Java works. So that's why we prefer double most of the times and not the float. So let's say 5.3, and then c1.show result. Since it is a non-static method, the show result is a non-static one, so we have to call it with the help of the reference variable. So we will save it, and now let's try demonstrating it. So Java C demonstrate dot Java, we have the n demonstrate. Okay, Java C circle dot Java and Java demonstrate. We got the values. We have the radius. So basically we wanted to check that the radius is going there or not. So yes, it is going there perfectly. So radius, diameter, area, and then the circumference. So all of them are by default 0.0, which is the default value for double. So that's why we got the diameter, area, and circumference as 0.0. Now we would create another function, calculate parameters. Instead of creating different functions for all of them, we can just create one, because it will be a single statement function. So that's why we will just create one function which will contain all the three statements for calculating them. Now before that, it is important to know one thing, that like pi has its own value already, like we know the value for it. So we can define it as the literal. So it is pi 3.14. Now I have a question that, let's say if we create 10 objects for the circle, let's say circle C1, C2 up to C10. So how many bytes will it take? Let us calculate. So we have 5 of them over here, radius, diameter, area, circumference, and pi. So there are 5 double variables, and double consists of 8 bytes. So each of them will have its own 8 bytes. So one object will occupy 40 bytes. And let's say if we have 10 objects, it will occupy 400 bytes. But is it necessary that pi is different for everyone? No, pi is not different for every circle. There might be all the 10 circles with different radius, and thus they have the different diameter, area, and circumference. But pi is universally same for all the circles, and thus we do not want it to take its own space. Like for example, let us take a look at the memory map. It is better to understand using it. Let's say we have this area, not the area of circle, but just an area, and this contains 5 objects, or let's say 3 objects, 1, 2, and the third one, 3. Now each of them have their own 5 variables, 1, 2, 3, 4, and the 5th one is the pi, so 5. And same for everyone else, like the same 5 for this one also, and then the same 5 for this one. But the pi which is having the 3.14 as the value, it is same for all the circles. And since it is same, so instead of keeping it in all the objects, like having it again here in this object also, like this is the radius, diameter, area, circumference for perimeter, and then we have the pi again. Same for this. So instead of assigning pi to every single object of the circle class, what we can do is we can take the pi static. So we can take it outside. We have the pi here, and we give it its own space, 3.14. Simple. We do not require to keep it in all of these objects, even if there are thousands of circles which we are creating. Let's say there are 1000 objects. So how many bytes will be occupied? There will be almost 40 multiplied by 1000, which is exactly 40,000 bytes will be occupied by the 1000 objects. But if we take the pi as the static variable, since it is common for all, it is global for all the circles. So if we take it static, then there will be a huge reduction. Like if we just instead of the 40 bytes, now one object will not take 40 bytes, but it will take just 32 bytes, because the pi is static and it is outside of all these objects. It is not related to them, but those objects can access the value of pi. So in that case, one object will take up 32 bytes as the space, and thus 1000 will take 32,000. So we are saving 8,000 of them. And there's a difference between two words. Like when I'm talking about that how many bytes will be taken by the object, so the answer is 32,000. But when I say that how many bytes will be taken when the program is executed, then the answer is 32,008. 8 for which variable? 8 for the pi. Because pi will also take up its space, which is the 8 bytes, since we will keep it as double. Although we can keep it as float also, and it will take up 4 bytes, but we can give it as double because Java works in double, and since we will calculate all the things, so we can have it double simply. So let's get back, and instead of giving it here, we will make it another statement. So static double pi, which has the value 3.14. Okay, first we should complete the calculate parameters. Since we have the pi here now properly set, so we will calculate all the parameters required, and we have the radius. Now first off, let us calculate the diameter. So diameter is equal to radius multiplied by 2. Okay, double of the radius is the diameter. Then we have the area. Area is the pi r square. So pi into r, or radius, not r in this case. So pi into radius into radius. We will not use the method for the square of radius. Instead, we can do this simply, radius into radius. Okay. Now, third thing is the circumference. So circumference is equal to 2 into pi into r, which is radius. Make sure you remember the variable, because according to the formula it's 2 pi r, but we should write the radius or whatever we have took, like if we take it as rad. So in that case, we have to write the rad for all of them. So in this case, we will take the full names. So radius. And now we have calculated all the parameters for the following, like the diameter, area, and the circumference. Now let us try to execute this once again. So P1 dot calculate parameters. So now let us try to demonstrate this once again. So we will just recompile all of them because we have made changes in both of the classes. And we got all the values. So 5.3 multiplied by 2 is 10.6. Then we have the area, and since it is the double, so we have a huge value like 88.2025 and then 9 lots of times. Then we have the circumference 33.284. So we have calculated everything of the circle necessary. So let's head back. Now there's a small flaw here, that since pi is static, so without even accessing it with the help of the reference variable, I can directly access it from here. Let's say circle.pi, and there's a vulnerable chance that we can change the value for it. Let's say I keep it as 1.14. So is it correct? No, the value of pi cannot be changed. And if I just keep it above and I save it, Control S, let's try to compile it. Just to demonstrate, we just made the changes to demonstrate, and it is interfering in all the results. But we don't want anyone or even ourselves to by mistake change the value for the pi. Although we will not change it, but there might be someone else who might take the source code and then change the value of pi. But we don't want anyone to change it. So what we can do, the solution for this is simply making this variable constant. And how do we make the constants? With the help of the final keyword. So let us try to run it again. We should get an error that we cannot access it. Let us compile all of them, demonstrate, and look, we got the error. It is the compile time error when we are trying to compile the demonstrate. So we got an error that cannot assign a value to a static final variable pi. And the circle.py, it is giving the error here. So since it is a final variable, I cannot change the value of it from anywhere. Now, is there any chance that there might be some value which is final but not static? No, there is nothing like that. Why? Because suppose if there is a value which cannot be changed. So, if we have a value x here, and let's say its value is 1000, and we don't want it to change, and we have given it as final. But is it possible that we do not give it as static? Like we do not mention the static here in this case? No, it is not possible, because let's say we have two objects, this one for the hypothetical class we are talking about, and this one, and we have the x inside both of them, because since it is non-static, so it will occupy its space in every single object. X. Since it is final, we cannot change the value. It is 1000 here, 1000 here, and we have defined it as a literal. So since we cannot change it, so why don't we just take it as the static also, like we just keep it outside of this, like here, and we give the value. Because if we cannot change the value, thus it is global for everyone. Like it's what obvious that when we are not changing any value, so in that case it should be global and it should be accessible to all the objects, instead of just occupying the extra space for the x variable here, which will occupy its own space. Let's say it's an integer, so it will occupy 4 bytes and two objects make up 8 bytes. Whereas if we have it outside, so even if there are 1000 objects, but the program will occupy only 4 bytes. So this is why we never use just final, but even if like if we are thinking of taking a variable as final or making a variable constant, then we should assign it the static as well and make it global. But vice versa is not possible. Why? Because sometimes there might be some value which is changing after each minute, each second, but it is not final. Why? Because it is being changed, but it is static for everyone. So we will take an example for this as well. So let us go back to the code. So since we are talking about the designing of the class properly, so what we can do is we can just call the function right away from the constructor only. And we can also do another thing, which is we can call the show result as well. Because why do we wait for the user to tell us that yes, show the result? Obviously, the person wants the result for the diameter, for the area, for the circumference, etc. So we will just simply give them a call from here only and we will remove it. So whenever an object is being created, the constructor gets called automatically and both the functions will get called. First, it will calculate the parameters and then it will show the result of them. Simple. Now let us create some circles. Let's say C1, C2, C3. So let's say we have 5 circles. So C1, C2, C3, C4 and a C5. Let's assign them some different values. Let's say 6.3, 7.1, 2.8 and let's say 4.7. Anything we can assign. So we are assigning some random values as the doubles. Even if we don't put this, like even if I remove this, it will still pick it up as 5.0 and it will calculate accordingly. So let's just keep one of them as the integer only. And now let's run the code. Now let's clear the screen. We don't like errors. So we will just recompile all of them once and we will try to run them. So Java demonstrate. And we got the values. So the radius it automatically picked up as 5.0 and not just 5. Why? Because it was double. So the diameter was 10.0. Area is also simply calculated, which is 78.5. The circumference is a bit too long here again, 31.4. Then lots of times zeros and the 2. Then we have another circle. It's a bit messy, so let's just put a next line character over there. Here we will do something like this, system.out.println. Let's just recompile them. I don't know why I'm recompiling the circle, but even if we do so, then there's no problem. We have all the 5 circles with the desired output, with the desired area and circumference. Okay. Now as I was talking about that a case where there is a static variable but not a final one. Because in the case of being final, it must be static because it should be global since it cannot be changed. But is there a case where the variable is static but we don't take it as final and we don't want to change the value? So let us take an example of an identity for each and every circle, because till now in the result we do not know that which circle are these. So what I want is that I will give them ID for each of them, like a circle ID for every one circle, and it will be assigned accordingly. So let's go back to the circle, and here we will take not the double, we don't require the 0.0 behind it. So simply let's keep it here, integer, let's say circle ID, simple, and by default we keep the value as 1, because when the first object is created, its a circle ID will obviously be 1. Let us give some comments for better understanding. So those are the parameters of circle, and this is the final. We can already read it. Constructor. Then we have the other functioning methods like the calculate parameters and the show result. So we have those other functioning methods as well, and we are giving them a call through the constructor. And there's another great thing in Java that we can create multiple constructors. So we will just change the heading to the constructors. And as I discussed in the class for the constructors, so in that I told about the default and the parameterized constructor. So this one is a parameterized one, and we can create a default constructor as well, which does not require any value to be passed, and thus we will give it the radius as 0, and we can just calculate everything, calculate parameters. Then we have the show result. Simple, pretty similar to this one, but instead of getting the value from the user, we just simply have the radius is equal to 0 or 0.0, anything. It will by default pick up as the 0 only. So let us just recompile it and try to run it first. Let's say if we have this one as empty, third one is the empty one. So it should pick up the by default constructor, which is the 0 value constructor. And yes, the third circle has all the zeros in it. So we can simply have a default constructor for the person who might have forgot to put a value or who is trying pressed about a program. So if the person is not entering anything, so in that case, the by default value will be 0.0 and thus everything will be calculated by 0, getting the output 0. Simple. Let us head back, and since we were talking about the circle ID, so let us just assign the circle ID to each of the circle. Let's take it as we should not give it anything, and we will keep it here, or maybe like circle ID. So we have the circle ID. Let's just keep it a little below the radius. Circle ID is equal to let's say 1, and same thing above, circle ID 1. Here again 1. But now the problem is that when we are creating 5 of these objects, even one of them is calling the default constructor. So all of the circles will have the circle ID as 1 only. There will be no change in the circle ID. But what we require is, we want the circle IDs to be in the ascending order. So let us just try printing the circle ID just for the identification, and we will take an example for the just static and not the final variable. So what we can do is, we can count the number of objects coming up. So simply we will take a counter here. Let's say int object counter, and by default the value of it will be 1, and we will keep on changing it. And now here what we can do is, instead of 1 giving it as a literal, we can do it the object counter. So by default the value is 1, so 1 will be assigned to the circle. Same in the parameterized one. So object, because we want to count the number of objects or circles. So technically they are circles, but actually they are the objects of the circle class. Now object counter plus plus. So now whenever the constructor is being called, so that means there is one object, and thus the object is being created. Or instead of this, there's a much better way that we just keep it above. So we first like add up the value, and by default int is 0, so we will just have the 0 value, take benefit of it. So it will be above this. Okay, so now it's perfect. Now whenever the constructor gets called, it means there's an object being created, and when the object is created, the constructor gets called. And when the constructor is called, let's say we talk about the parameterized one. So here, first of all, the radius will be assigned from the r variable. Then the object counter will increment its value, which is object counter plus plus, the post increment. Then we have the circle ID as of the object counter. So the current value for object counter will be 1, because there's just one object who has called the constructor yet. So the object counter's value is 1, and it will be assigned to the circle ID. Then we have both the methods. Now let us see, after this second object is being created, let's say this one, again the call goes to the constructor, and inside this constructor, now what's happening, again the radius is being given, and then the object counter plus plus means now the objects are 2, and then the circle ID has the value 2. So let us test it and run it. I will tell you with the help of the diagram as well, if it might be a little confusing. And we are getting the IDs, but there is one issue. So let us check what's the problem. Actually, the issue is that since it is also non-static, so let us take the help of the diagram only. It is understandable much better. So why the error is coming, although I knew it already. So this is why it is coming. Let's say we have the two objects we were talking about, this one and then this one. All of them have their attributes. So instead of creating four boxes, I'm just creating one huge one. So it has the radius, it has the diameter, area, and the circumference. So these are four different variables for each and every object. So this, then this, and again we have this. Simple, better. So we have the radius, diameter, area, and the circumference. Now, since the pi is static, so it is somewhat outside here, and we have the pi, which is 3.14. And we have the circle ID for all of them. So one is the circle ID, here and here. So let's just write it as CID, which is the circle ID. Now, we have another one, which is the object counter. So when we have the object counter here, let's say, and it also has it here. So let's say it is the OC, object counter, short form of object counter. Now, since all of these objects have their own object counter, so in that case, whenever an object is being created, so the object counter plus plus and the value will just be the 1. And then this one is being copied to the CID. 1 here, and it is being copied here as well. So 1 here. And this is the reason why we have an ambiguity here and why we have the 1 as the circle ID for all of them. So what we can do is, instead of having this object counter right over here, like we should just remove it from here, and we can simply make it static as well. It is here outside of it. So let's just keep the full name, object counter, and it will keep on incrementing because we have written the statement object counter plus plus. Although this particular variable is static, like we have to take it static, let us just take it the static one first. So static int. That is why I took it in the other statement and not with the circle ID. So it is static, but it cannot be final. Final in this case is not possible. Why? Because whenever an object is being created, let's say there's a third object, a fourth one, there's a fifth object being created. So all of them need their own circle ID. It has, let's say the circle ID for this is 1, 2, 3, 4, 5. All of them have their own CID or the circle ID, and the object counter keeps on changing. First, the value for it was 1, then it goes as 2, then 3, when this one is being created, then when this is created, then the value is 4, then 5. So this is how object counter keeps on changing, but it cannot be taken as final, because if there are 1000 objects, so 1000 times it will be changed. But it should be static. Why? Because if we take it as non-static, it will be present for each and every object, and thus we will get the circle ID as 1 only. So let us try running it, and we will recompile it. Circle.java, demonstrate.java. I don't think we have created some change, but still. Now we have the circle ID properly assigned. 1, 2, 3, 4, and then we have the 5 below it. So this is how it works fine. Like we don't need to have it as final, but it is just static. And in the case of pi, it must be final and static as well. So this is the code for it. Like we have the circle class and we have the parameters of circle, radius, diameter, area, and circumference. So let us summarize like what we have learned. And so first off, we have the parameters of circle. Then we have the circle ID. We have some two basic variables defined for the circle ID. One is the integer circle ID, and then we have a static integer, which is the object counter. And in the case of pi, we kept it as final static because we neither want it to be changed and it must be global as well. So whenever you think of taking a variable as final, take it static as well. Then we have two constructors. We learned that we can have more than one constructor. So in this case, we had two constructors. One is the default and then the other one is the parameterized. Then we have some other functioning methods like the calculate parameters and the show result. And let us take a look at the demonstrate. So we just simply created 5 different objects. Even if we create more objects, like talking about 10 of them, and even we can do one more thing. Instead of all these statements, we can simply write new circle. Let's say 5 and just copy paste this statement. It's much easier. So let's say we keep it 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So those are the radius for them, and since we are using the on the fly objects, so it is also good for memory. So now our programs are successfully the best memory savers because we have took the static variables also so that we can save the memory. And in the case of demonstrate, we have the referenceless objects which get destroyed once their work is done. So let us just see the demo for it. Clearing the screen, compiling both of them, and we have the same output. So this is how the on the fly objects are very useful, and we covered another topic in this, which are the on the fly objects. Like we saw the real implementation of them. So they are very useful in case of the memory saving, and this is how we created a proper memory saver program, which is the circle.java and the demonstrate.java. So that's all for today. I hope the video was insightful, and if you have any questions related to the circle class or the different implementations we did in the today's class, you can comment down below. And thank you very much for watching. I will see you in the next one.